Okay, ready? Get set?
Yeah, okay.
Go.
Hello everyone, I'm Gemma from APAN JP NOC. Today I'd like to talk about APAN JP update here. So the APAN JP backbone configuration is currently as shown as in the figure. We have 3 major POPs located in Tokyo, Hong Kong, and Singapore. And the main path of APAN JP is JJN Japan Hong Kong link and Hong Kong Singapore link. We have for backup paths now, from high to low priority. The first is NREN Japan Singapore link. The second is path of Arena Pack and Guam Singapore link. And the third is path of Arena Pack and Arnet link. And the last is Core link. Actually, this backbone is not only used for Japan, but also used for the communication, such as from Singaporean to American. We have greatly improved the resilience of APAN JP's backbone with the addition of backup links now. As a result, even though APAN JP's Hong Kong Singapore link experienced a month-long outage this year, it was able to maintain backbone availability of more than 99.9%. So thank you all for your cooperation. And then I'll talk about interconnection of global R&D circuit. First is the availability of the circuit. We asked several organizations about the last 4 months of the failure and maintenance time and calculate them as availability rate, then create this map. In this map, link with availability over 95% are green, and from 90 to 95% are yellow, and then stay 90% are red. As you can see, more than half of the links actually failed to achieve 95%. The reason is that the submarine cable often fail due to earthquake, landslide caused by typhoon, and ship anchors. And once they fail, it needs to take a long time to restore them. So maintaining an update of 95% is not very easy. For this reason, mutual cooperation between organizations is extremely important. And Japan said not only reduce to the overseas organizations link when our links failed, but when the overseas organizations link failed, we also provide reduced link to them. For example, when Korea-Singapore link disrupted in April, we rerouted it to JJN Hong Kong Singapore link. And when Guam Singapore Consortium linked down in May, it was rerouted to the NREN Japan Singapore and Japan Guam links. This kind of mutual cooperation between organizations improve the quality of our networks. And go to next topics, community of international R&D network. There are many community of international R&D network in various regions around the world now. Japan also currently participated in several communities, including AER, APONET, and ANA. There are many benefits to expanding GXP and participating in this community. It is not only can provide backup connectivity to improve resilience I just talked about, but also can support high performance data transfer on a global R&D network, can cooperate on deployment of new network technology and service, can enable development of applications that require high bandwidth and more. Finally, a summary of good side effects and improvement. I talked about the expansion of the APAN JP backbone has increased the network's resilience, and participation in several community have led to active mutual cooperation with overseas research and education network organizations. However, inadequate capacity planning during reroute has resulted in a traffic overflow situation during failures. So for this reason, we have started to consider ways to share information between each community, and such information sharing by each community is expected to further research and cooperation activities using international circuit in the future. Thank you very much.
Whoa. That was amazing. Oh, you get to speak very fast, right? Okay.
It's a great pleasure for me.
Now you understand the pressure.
Yeah, it's okay.
You ready?
Yeah. Okay.
Okay.
Yeah, let's start. Yeah. Hello everyone. I'm Jiang Ning from CSNet, China Science and Technology Network, and I'm the International Cooperation Manager in CSNet. Oh. And thank you for having the opportunity to give an introduction on CSNet update. And this is some information about our international cooperation. In June this year, in TNC 23, we signed the new 100G circuits agreement with Giant at the TNC 23. And in this cooperation, we upgrade the connection between Beijing to Hong Kong and Hong Kong to Singapore to 100G. And we also set up a new exchange point in Singaporean SOE1 at Global Switch. And also on yesterday's opening ceremony, we signed the MOU. That's the cooperation between our Asian partners. And we are happy, and we would very like to cooperation with our Asian partners to give the support and contribution for the global scientific applications. Yeah, and because for CNET, we didn't attend each APAN meeting. Yeah, so I also prepare some slides about some feature and mission of CNET. For us, we near most major research infrastructures and the national scientific data centers, scientific computing centers have direct connection to CSNet. And so our mission is to support some major international cooperation projects at ITER and SKA. And that some typical application running on CSNet, basically we support the national research infrastructure have big we will provide a high bandwidth connection for them. And also we support some typical application like national scientific pilot plan and international cooperation plan. Yeah. And this is an example for a pilot program, the ground communication network and the data processing for space research. Yeah, in this application, we provide the set up the scientific VPN transmission and provide the offsite disaster recovery system and also data processing and management services for this plan. And also we are certain to provide 7/24 operation to guarantee their application. And this is the example on major research infrastructure application. That's fast. I think most of you are familiar. And then for CSNet, we not only provide the direct connection for fast, but also we have developed the software platform to help fast identify the newly discovered pulsars. Yeah. And that's an example on high energy physics. We support many like a particle acceleration, the neutrino experiment, the cosmic ray experiment, and some space cosmic ray experiments for IHE, high energy physics. And then some application like ITER. Yeah, ITER help the 7 partners to work together to solve the problem and do the contribution to human beings, because it's do the research for the future energy for all of us. Yeah. And this is example, SKA, that's also most of us familiar with it.
And that's the slides. Yeah, that's the next step plan for CSNet. That's the domestic network. Yeah. Next year we will start to construct a new network in China, because we are national level the network. So we can see that that's infrastructure including many rings, and each point there will be a 200G and 400G megabit gigabit bandwidth with each other, with each points. And the backbone, including Beijing, Guangzhou, Shanghai, and Chengdu, and also we will have also have international cooperation. Yeah. Okay, so. So last sentence is that the new infrastructure will contribute and support the scientific application, and also to support the new technology experiments. Yeah. Okay.
Thank you.
Thank you.
Thank you very much. Next will be Jonah. Okay, ready? 1, 2, 3, go.
Good afternoon. Thank you, Francis. I'm Jonah Keogh. I'm the managing director of the Pacific Wave International Exchange. It's been a while since we presented at an APAN meeting. Just as background, Pacific Wave is a joint project of CNIC, which is a regional network in California, and Pacific Northwest Gigapop, which is a regional network that I work for in the Pacific Northwest in the US. It's an open exchange that supports both commercial and R&E peers with a real focus on high-speed research. We serve 29 countries across the Pacific, connecting into the Western US, and we're supported in part by a grant from the US National Science Foundation. So, we couldn't do what we do without the support of all of our partners. And, this map really shows all of the contributions that the partners bring into the Pacific Wave infrastructure. We operate backbone infrastructure that connects Seattle, Sunnyvale, and Los Angeles together. And I'll be talking a little bit about our upgrade plans there. But, the key point here is that we have a lot of interconnectivity across the Pacific. And we really seek to provide services to the R&E community that allows them to leverage those investments. And when we look at all the diversity afforded through the backbone in the US and the diverse connections into Seattle and Los Angeles, something that we're really excited to be able to support and continue to evolve with the APAN community. There's some additional information here about the specific POPs that you can look up if you're interested in connecting into Pacific Wave. And I'll focus on some project area updates across a couple of key things that we're working on in our project. So the first of those is traffic monitoring through a project that we're working on with our partners at UCSD. And this is some flow-based traffic analysis that allows us to provide insight into flows and specific research flows and traffic areas and performance issues. And it's been in the initial deployment stages, and we're kind of learning how the tool works a little bit, but it has definitely provided some insight into a different way to collect data than we traditionally have done on the exchange point performance. And that's definitely been really insightful as a way to reach out to researchers and improve performance for folks that are experiencing issues. So there's, again, some more information here that you can look at. We've also deployed in a different area route servers on the exchange. Traditionally, Pacific Wave had been exclusively a layer 2 exchange point. We now offer route servers, and there are a few people in the community who are peering with them. And it also provides a way for us to implement some of the manners recommendations by filtering routes to the route servers and improving our community routing security. So there's kind of twofold benefit of peering with the route servers, both that increased security through filtering, as well as an easy way as more people participate to join the exchange and not have to reach out to every single participant to establish BGP pairs. We're also working on upgrading the exchange to 400 gig. We've received Juniper PTX hardware, and we're planning on deploying it in the next couple of weeks, months, depending on which site we're looking at. But we'll have that deployed across the West Coast backbone. And right now we're at 2 by 100 gig on most of our backbone links, and we'll upgrade that to native 100 gig at the same time we deploy the PTX hardware. We're having early conversations with folks in the community who are interested in landing 400 gig connections. And I know there's been some talks about connectivity to Tokyo and other places. And we're certainly happy to have those conversations. On the backbone side for our infrastructure, we're already seeing capacity needs to justify that upgrade for the West Coast backbone. And we'll be ready when the Trans-Pacific capacity is there. So we're continuing to monitor progress in the Arctic. I think there have been a lot of conversations in the community about that. If there's an option for connectivity that drops in Alaska, we'll certainly be, at the table to discuss the best way Pacific Wave can support that with our infrastructure. And I know a lot of people have talked about partnerships in the community. This is a US focused partnership that is called APREX, and there will be some evolving of that we're working on to include some folks from FIU and from Starlight to include more of the US exchanges in the coming year. And we hope to have more to share about that in the sort of TechX SC23 timeframe. And then again, the partnership that we're really pleased to participate in that's shown some dividends with some recent cable cuts on cables to Guam and other places where we've seen traffic fail over through APONET. So I really appreciate the time to give you a quick overview. And if any of these things sparked interest, please don't hesitate to reach out to me or any of the other folks on the Pacific Wave team. And thank you.
Thank you. Next, you have Edward from Transpac. How do you like this speed of presentation?
If I'd known it was a competition, I would have made it endlessly more entertaining.
Yes, when he's smart. We'll see how fun it is. Anytime you're ready.
Yeah, I'm ready to go. Yeah. So, hi, Edward from International Networks at Indiana University. We're a small research team devoted to operating international networks on behalf of US science collaborations. One of our current projects, as many of you are aware, is called TransPac, NSF-funded project that provides 100 gig connectivity between the US and our partners in the Asia Pacific region. Happy to do this quick update for you. I think the biggest update over the last year or so is transition and recomposition of our team. As you see here, I've been given an opportunity to lead the team, and other people who I'm sure you're aware of. Hans Adelman is leading the technical direction for the team. Unfortunately, he's not here. He's busy leading SciNet back in the US. Brenna is leading our architecture and engineering team. Brenna is here. She's in the back. Everybody knows Brenna. If you haven't had a chance to say hi to her, please seek her out. It's Brenna, not Brenda or anything else. And finalizing our team is Heather Hubbard, who keeps us going in the right direction. Jim Williams, who temporarily took over our team, is still on as an advisor. And he'll continue in that role until the end of the year, where he'll happily once again retire in peace. And we're happy to be given the opportunity to lead TransPac, which has been a successful collaboration in this community since 1998, with the first award given to Michael McRobbie at Indiana University, who just 2 years prior, 1996, had helped establish this community, the APAN community. That first award was 35 meg connection from Chicago to Tokyo. Over the years, as you can see, it's increased bandwidth to 100 meg, 155 meg, to 110 gig, 210 gigs, then up to 100 gig, where we've been for 10 years. And TransPac 5 is the current iteration, where we have 100 gig with our partners at Pacific Wave connecting Seattle and Tokyo. And more recently, with a larger consortium, 100 gig circuit connecting Guam and Singapore. But if you see, we've been I think there were investments by the US community with NREN involved around 2014 on 100 gig, but Transpac provided majority of US funded connectivity to this region for many, many years. And we've been on 100 gig, believe it or not, since 2015. And we're looking towards the future. We're starting to have conversations about what our future endeavors and future opportunities might be. And we're here to have conversations. There's some have started already, and I'm sure over the next year, next few years, we'll be able to further define as the strong partnerships are coming together, as everyone who's presented here so far has highlighted. There's a real momentum now in the community. Maybe we're post-COVID. Maybe certain projects that were stalled are now picking back up again, but I'm feeling a real momentum in this community to start looking towards the future. And for us, the future is a number of things. Primarily, we're looking at advancing some of these global collaborative systems that, again, we've talked at length about. We're committed to being a part of these systems, but also committed to help leading them. We're currently the chair of the APAN engineering group. We chair the ANA engineering group. And part of our work going forward will be to define what our collaborations will be to helping evolve those collaborative systems to the next generation. Now, for example, the APONET used to be APR, and we advanced it into APONET. Sure. And the next generation is what we're thinking about. Jonah mentioned 400G. Those conversations are happening. It's happening in the Atlantic, moving towards Spectrum and 400G. It's a matter of time before the market stabilizes and it's available in the Pacific. Leveraging strong US partnerships like APREX that Jonah mentioned. We're continuing our science engagement application support work within the routing working group using NetSage, continuing end-to-end performance improvement with some of our larger users. And finally, supporting network research and experiment. We're supporting the international component of Fabric Testbed. We're supporting DMC, supercomputing demos, AutoGoal Sense, and others. That's it. Those are our updates. Here's where you can find me, and happy to have discussions throughout the week. Thanks.
Wow, right. We next have an update of the event. Take a deep breath.
Yeah.
Ready?
Yes.
Okay, go.
Okay. Good afternoon, everybody. This is MD Ariful Islam from BDN. I'm working there for Manager Data and Transmission. This is the first time we are actually presenting update about BDN. And thank you for giving me the opportunity. So first, I'd like to introduce how it is actually from. This is the same goal as then with the other NREN community. BDN has been established in. Basically, BDN is working from 2010, and the official trust organization has been formed in 2014. This is the backbone structure, our architecture of our network. We have it is a MPLS backbone network. We have 8 different distribution over the country, and we have 34 different location POP, and all the clients are connected with the 34 different POPs, and we have the 20 GBs and different upstream provider as well, including the telecommunication. So how we actually connected our members institution? We use actually, there is a MU sign between the Bangladesh Power Grid Company of Bangladesh and the BDN, and we have 4 kilometer basically OPGW cable from the PGCB, and to connect our member institution, basically last mile we have deployed 450 kilometer underground optical fiber across the country. and we have formed a DWDM-based transmission network. This is the network of the DWDM network. And using the DWDM network, we have altogether, though we have the 40 lambda capacity, but still now we have the 29 10 Gbps circuit to connect our distribution network, and the 34 different 1G circuit sometime connect to our member institution directly. This is the top-down approach of our network. So with the network we have, we can actually provide the availability to our member institution is about 99.90%. And the University Grants Commission Authority come up with a decision that only the university, they are connected with the BDRAN, they should have only single connection of BDRAN. So BDRAN, with the decision, BDRAN take another step to connect the university with a backup connection with the other entity, and like state government, Bangladesh state-owned another company. This is Bangladesh Telecommunication Company Limited with the separate transmission backbone. And now we can provide our institution availability of 99.95%. And we are expecting to give them 99.9%. And this is the, as usual, the 10 connectivity. We have a 10 connectivity through the NKN, India. And now its capacity is 1 Gbps. So we're expecting to update this link very soon. And this is the membership status. We have altogether around 200 members. And among the 200 members, we can connect. Our connectivity has the 76 connectivity, including the private universities, public universities, medical colleges, and the research institution. This is the upstream bandwidth information. We have two different upstream. Both are government owned upstream. That is Bangladesh Telecommunication Company Limited. We have the 15 Gbps with the Telecommunication Company Limited, and we have the 5 Gbps connectivity with the Bangladesh Submarine Cable Company Limited. Okay. So we have also different peering, and that peering with the National Data Center and the telecommunications company. This is the growth of our internet. So it's unlike exponential growth since 2021. This is the graph information, bandwidth information of our chain connectivity, the steady growth. And you will see the last month, it is almost full capacity, occupied the full capacity. And this is the service we are providing to our members universities. Some are the cash cow, the internet service. We have the flagship service like the on-prem Zoom and the Eduroam service. We have the widely used service like SPC and the GPO processor service. And the other service we have out of the box than the RAN actually do. We are planning for the new services, digital certification and the verification process. And I would like to conclude my presentation with the good news that with the first RAN actually enable the Eduroam in our international airport. And this is the statistics this month, August. We have seen that there are about more than 1,000 users has been logged, and since June it has been more than 2,000 users actually. Thank you. Thank you so much.
That's amazing. And in fact, I was about to say that NREN has totally needed bombs. For them 30 years now where they are. Next we have Kama from Bhutan.
Yeah, I'm ready.
Okay, so
Yeah, hi, I'm Karma from Druk Research and Education Network in Bhutan. So I belong to Government Technology Agency, the agency responsible for operation and management of Druk Research and Education Network. So I have some few updates. Okay, so this is the backbone. We have built a multiple 10 Gbps network, Druk Research and Education Network, connecting all the research and education institutes in the country using the National Fiber Optic Backbone Network. So we lease a pair of fiber. And recently, since the last APAN, we have managed to improve the resiliency in the backbone network. As you can see in the map, all the red highlighted links are the new links that we built. So we have now east and west redundancy. We also have the central and western redundancy. So we have built around 5 to 6 rings, and this has greatly improved the resiliency of the network. Prior to deployment of this link, the uptime of the backbone network was 99.96%. With this in place, now we are hopeful that we'll be able to provide 99.99% uptime to all our members. And we still have 5 gig link to NKN, which is being provided by NKN, and we have transit to the Global Research and Education Network via NKN. In this meeting, we have had a discussion with NKN SIMA and also Francis to how to go to Singapore so that we can have more control and peer with other research and education networks. So we are hopeful by next few months we'll be there in Singapore, and we request everyone to peer with us. And in terms of the connectivity, we have managed to increase the number of institutes connected to NREN from 251 in March 2023 to 260. So as you can see, we connect not only the research and education institutes, but also the schools and hospitals. Apart from that, we also connect the national libraries, national museums to our network. All these institutes are connected with 1 Gbps circuit. Some more updates in terms of the deployment of IPv6 in NREN. As you can see, the highlighted box, we are standing right now at around 40% IPv6 capable, IPv6 preferred, and NREN Research and Education Network is the #1 V6 in terms of the V6 deployment in Bhutan. This table is taken out from the APAN Stats Lab project dashboard. So thank you, APAN. So in terms of the future plan, we are working towards further improving the resiliency of our national backbone network. So we are in the process of introducing the first 100G link between Thimphu, capital city, and the Jamgang district, which is located in the central Bhutan. So we hope to meet the demands of our research and education community in Bhutan by introducing this first 100G link. And we are also working closely with our international partners to see how we can also have a resilient international research and education network link. So I think we have had a discussion with Francis, NKN, and also with the WIDE project to further improve the resiliency of the global research and education link for NREN Research and Education Network. Thank you.
The 5 minutes. Yes. Okay, the next speaker will be Simon Peter Green from NREN.
Okay.
Sure.
Yeah.
Okay.
As ever.
Okay, go.
Okay. So I'll be providing some updates on the NREN Open Exchange. So just a quick background. So NREN is the Singapore's research and education network, and it was incorporated in 2003 as a non-profit society. And we basically do the dedicated local and international connectivity for irony. As of APAN 55, this was the topology with SOE1 and SOE2 being our main POPs in Singapore. And now in APAN 56, we've had the completion of the IC1 circuit from Jaeon to SOE2, CSTNet in Hong Kong to SOE1, and also the additional 10 gig to Google at Global Switch as well. So in regards to the infrastructure that we run, the routers that we're using, we use at SOE1, we use the brokered MLXE8, and we're actually planning to upgrade this equipment in the second half of this year. At SOE2, we're using and this is at Equinix SG3, and we're using the Extreme Networks SLX9640. This is a 1U router as a switch, and it's I think this is what we want to move over towards on SOE1 as well. So in regards to people who want to connect into Singer and Open Exchange, the circuit will need to be borne by either the international partner or the local institution. This includes the cross connects at SOE1 and SOE2. For peering services, need the usual public ASN, public IPv4 address space, minimum /24, and public IPv6 space of a minimum of /48. And for VLAN services, the partners or institutions need to provide us with the proposed VLAN or VLAN range, and also the path to reach the partner institution, and we'll help to facilitate that. And some details on the SOE1 side. So here is basically where we're located, the ASNs and prefixes that we use. So for this, we use AS23855 as our ASN, and the prefix is 203.3038.23. And for now, we support both 1 gig, 10 gig, and 100 gig, but once we upgrade our system, it will only be 10 gig and 100 gig. Following on from this, we have our SOE2, and you'll notice that we use a different ASN for this one. It's under 134.148 and a different prefix too. And this is at Equinix SG3. And for this one, we only support 10 gig and 100 gig for new connections. In regards to the BGP policy that we do, as most of the other NRENs do here, we use community tags and community access lists to manage the BGP policies between members. And we also make distinctions based on the type of institution or partner connecting in. For more details, and likewise for finance and subscription, Binlay would be the person, and then for technical, it would be myself. And following on from that, I'll go over just some brief updates on the Data Mover Challenge that's been running over this year. So this is DMC 23, and it's a competition that's held every 2 years by the National Supercomputing Center, and it's supported by NREN, and it's for teams to showcase their solutions for transferring large amounts of data globally using the RNE network over 100 gig data transfer nodes, or DTNs for short. So for this year, we've had 7 entries, and we have participants from Australia, Canada, China, Japan, Malaysia, and United States. And the DMC actually has already started on the 7th of August. We've got a break this week because of APAN, and then we're starting next week until the 29th of September. So this is the topology for the DMC 23 this year. And the great addition that we've got is last year we didn't have South America or Starlink. So now we've, with partners from Amlight and RNP, they've given us or provided us with connectivity to both Chile and Brazil. And for KDDI, providing us with connectivity over Starlink. So we thank you all for helping out with this. And then following on from here, so these are some of the test scenarios that we have. So we measure both the memory to memory and disk to disk performance. And these are between the different DTN nodes. As you can see, we've got Netherlands to Singapore, Australia to Japan, and so on and so forth. And last but not least, this is just some of the basic DTN setup that we've got. So they would definitely need to run 100 gig network interface cards, NVMe storage, and then we've got Persona running with regular testing. And then to actually deploy the solutions on the systems, we use container runtimes like Docker and Singularity, and then we use Node Exporter for monitoring and subtuning. Thanks.
Okay.
Yeah.
Just in time.
Yeah.
Okay, next speaker is Alexander on Serve. Where's Serve?
So it's here. Yeah.
Netherlands.
In the Netherlands. In the Netherlands. Yeah. Thanks. So my name is Alexander. I'm with Surf. Oh. Yeah. Okay. My name is Alexander. I'm with Surf in the Netherlands. and providing you a brief update on what SURF does, but only on a very specific topic. Because before the pandemic, we were known to most of you as SURFnet. And during the pandemic, we merged with several sister companies into SURF. And so it's just SURF now. We are a cooperative in the Netherlands, about 100 members on the higher segment of the education and research sector in the Netherlands. Besides networking, we provide a lot of other services towards our members. Supercomputing, it's supporting public-private partnerships, it's joint coordination of cybersecurity, and lots of other things. It would take me 5 hours to update you on this. So I'm only focusing on the Open Exchange in the Netherlands now. We in the Netherlands are quite known as a major digital port in Europe. We have a lot of good data centers. We have a lot of connectivity. We have the Amsterdam Internet Exchange, and we thrive on that with Netherlight as well. And I want to update you a bit on that. We just installed this quite big box in Amsterdam, and that forms the policy-free global exchange point in Amsterdam. And policy-free means really that every participant can peer with every participant in Amsterdam. And that's quite essential, as you will see later on. We upgraded to support 400 gigs, and these are the parties that are going to be upgraded really soon. And when you look at these maps, and we often look at those lines, but the GXPs on this map are really important. We see that we make a system across the Europe and Asia here. We also have a similar system across the Atlantic, and there are others. And the keeping track of those exchange points is extremely important, because we are also planning to move to 400 gig links there. So that's the reason why we upgraded both our capacity to Paris and in Amsterdam now to support that being connected. Well, back to Netherlight. These are more or less the countries or the NRENs that are connected to Netherlight at the very moment. We also connect service providers to that Open Exchange, so our members can use that, or you can use that if you want. And we work quite a bit with the other Open Exchange points in Europe, so in London and in Amsterdam. We form a sort of triangle. So that makes the reach even bigger from what you saw in the last slide there. So that means quite good connectivity to Africa, also across the Atlantic, and many other parties. The message that I want to bring across in this short update is that GXPs are really important here. They form the point of gravity where links come and go. But these stable exchange points will be there. We need to treat those very carefully, I would say. That's it.
Wow.
Yeah, I of course I can, as I say, it would take 5 hours, but chase me down in the hallway.
Okay, the next speaker is Panda. He'll talk about Arena Pack, which is making a major impact in the community. Yes, with your high speed.
Oh, yeah. Okay, so good afternoon, everyone. I'm Hiroshi Kasai, Call Panda, from the WIDE project. Then I'm going to share the update of the Arena Pack. So Arena Pack stands for the Arterial Research and Educational Network in Asia Pacific. So this is their arterial backbone, based on their 100 gig submarine cables capacity. So the Arena Pack is supported by their API DT infrastructure, and the operation is performed by WIDE project. So I'm going to present that. So so the WIDE project has been working on the research and educational activity was the SOI Asia and AAA project. So we're gonna extend that activity. That was originally by the satellite circuit, but now we are using the 100 gig submarine cable infrastructure. So this is their brief introduction of the Arena Pack. And we have three missions, and one is to develop the intra and the inter-regional backbone infrastructure with the research and educational network partners. And second is to promote the operation and development of a new Pacific topology. And third mission is to extend the infrastructure to the Asia Pacific to connect the Asia Pacific region to the rest of the world globally. So it's not only in the Asia Pacific, so it's a global project. So this is the current status of the Arena Pack. So we have Tokyo Guam 100 gig circuit operational, and the last month we had this month we had some kind of ceremony for the Guam Malang Indonesia circuit, and we have the Guam Quezon City Philippine circuit, but the equipment is ongoing. I mean, in process of the export procedure, so it's not up, but the circuit itself is up. And we have the Guam Singapore consortium circuit among with their RNet, Intent2, and Indiana University. So this is the Arena Pack backbone network. So the Arena Pack is operating the layer 3 AS autonomous system, and we are pairing with the wider project and the GXP Tokyo in Tokyo, and in Guam we are pairing with their Gorex. The Gorex has many partners, so we are exchange the route over the Gorex, and we have a direct pairing with the RNet and Singaren, so that we have a better traffic engineering. And we have direct link to the SINET in Guam. And we are pairing with IDLA and UB at Malang. And so we are now delivering the research and educational traffic over this backbone network. And this is the picture of the Guam site. So we have 500 gig per circuit going to the Tokyo, Quezon, Gorex, Malang, and SINET. So, and this is their new circuit. So actually the circuit was up since February, but we had a kind of startup ceremony this month. So I'm gonna share the information. So this was the information of the ceremony. So that is their yeah, we did some kind of demonstration using this Tokyo Guam and Guam Malang 100 gig circuit. We had an interactive 8K uncompressed video transmission experiment and demonstration here. And this is supported by SINET and the other partners. We are using SINET in a Japan circuit. So this is it. So this is the kind of the singing ceremony. So they're in Tokyo and the Malang, the people got sung together. So this is the traffic. We send about 42 gigabps both sides. So that was the ceremony. So if you want to know the detail of the ceremony, please let me know. I can share the video. And this is the summary of the Arena Packs. We're gonna soon have a Philippine and Philippine circuit. So that's all. Thank you very much.
I think the speakers are getting better after they're finishing before time. Well,
I have any
This is a new slide.
Okay, thank you. So I'm Dhammika Lanantha, network system engineer from lab. So this is actually not just an update, but all about learn. So I'll just present you the update only. Sorry for my. So for now, this is like public company limited by Guarantee Learn, so controlled by the UGC and the universities. So we have currently now we have 2 universities, main university added, so increase up to 18 full members. So and like other members, we have now slightly increased. And about staff, we had actually earlier very small staff, consisting 2 or 3 engineers, but right now we are increasing with restructuring plan and like having more salary restructuring, so to attract more people onto the more technically competent people into our company. So about transit and peering, only change few changes. Actually, we have Singapore link. Through that, we connect to the TAN and Google and other NREN networks. So we get these links from our local service provider through. So we have recently changed that. For our first, our service provider was Sri Lanka Telecom. So we have changed from to Dialog Telecom, Dialog Axiata. So that's a change. And we connected a few years back to the SLT IX. That's only available IX in Sri Lanka. And now we earlier connected with a few bandwidths, actually, as I can remember, 1 gig for testing, and later increase up from 10 gigabits to 20 gigabits. So it's almost used, so very utilized. So all other links are same. And so primarily, we use we don't have fiber infrastructure for our own. So we get fiber links from other from local providers. So only providers so far was for 4 years back was Sri Lanka Telecom. So we for the backup purpose for institutes, we brought 27 links from the other providers, Dialog Axiata. So we provide them on free of charge to the main university who had the main primary link over than 300 Mbps. So this is roughly the distribution map of Sri Lankan universities and institutes. So this is the learn basic connectivity to the world, and so how this shows how to connect to the Lanka government network and local other peerings in national knowledge of network of India, and how the transit links we are connected to. I think it's not much clear. So we connect to 10 pop through the single range switch, and also connect to Google and internet too through the single range. And EduRoam, yeah, it's currently we have 29 institute connected with that. About LIF. LIF is the Sri Lankan Access Federation. We are connected the 50 members, so we access education services through that, and also through LIF we connect to the on-prem Zoom services and EduVPN. Also, EduID is another kind of institutional database maintained by the Learn to provide access to staff and students who don't have access to databases, user databases or Active Directories. So Learn Tech. So we are currently recently started hosting cloud services. I mean SaaS for hosting LMS and WordPress Joomla for institutes. So it's on production. So it's using Kubernetes and SAP uses SAP node technologies and yeah, it's MariaDB. It uses MariaDB database, Galera database. About training and workshop we conducted last year. This is several workshops, 2 or 3 workshops we conduct for every year for the institutes. This is latest collaboration, so activities.
6 minutes.
Oh, sorry, this is last slide. Sorry, this is last. Actually, we connected with Cernet and things for the project of IPv6 network management. So it has had 5 sub projects. So we all joined with them, and that extended project from that the same project about BGP routing, analyzing, and diagnostic platform. We joined with that. So it detects the route BGP hijacking and mitigation and other route paths seeking and other metrics show in platform. So also we joined with the ICE courses we offered through the help through the collaboration with Indonesian cyber education. Sorry for 2 minutes.
No problem. We just deduct some marks from you.
Oh, okay.
No.
I
I
want-
can't. Otherwise, they're the host here. They kick me out.
You won't.
No, it's
Okay,
good.
it's okay.
Thank you. Thank you very much. Our next speaker is Amber from NREN.
Hi, everyone. Thank you for giving me the opportunity to speak today. I'm Amber from NREN. It's my first APAN. I've been in role about 2 years now. What I want to do is walk you through some work that we've been doing nationally to refresh our network, our backbone network. But first, just to give you some strategic context, NREN is focusing from network perspective on connecting researchers everywhere. We're very conscious that locally research is happening outside of institutions, so we need to rethink how the edge of our network works so we can support our members as they're out in the field doing their research. We have 3 strategic pillars. This program falls under connecting Aotearoa. Aotearoa is the native name for New Zealand, so you will hear that, particularly if you come and visit us, you will hear that quite a lot. So there's 3 stages to our national network refresh: backbone procurement, hardware refresh, and connecting in the field. We got a one-off government grant to fund this. It was a CapEx grant, so we've had to find the OpEx ourselves, but it certainly made a material difference for our ability to deliver this program of work. So the first phase was the backbone procurement. We were up against a burning platform. We had a contract that ended end of March this year. We went to market and we've chosen One New Zealand for our backbone supplier. You will all know them as Vodafone. They changed their name about 6 months ago. I really hate the new name, so I still think of them as Vodafone, but they are One now. The big factor for us locally in choosing a supplier is commercials. New Zealand has an excess of national capacity. Most providers have capacity along the same paths, so there's no real difference who you provide from a path perspective. The big deciding factor for us choosing One was the commercials. They gave us a capacity points model. That is where we buy capacity points for the country and we can move it around various paths as demand changes. And that's very, very important for us because finally, the big cloud providers are building data centers in New Zealand. That is happening at the moment. So we know that in the next few years that traffic patterns will change. So that flexibility was key. The other one was the resiliency provided using Sienna FlexGrid technology. They're the first network in New Zealand to have that, though the other providers are catching up. We have a lot of natural disasters and earthquakes in New Zealand, so that resiliency, the additional resiliency has been very important for us in the decision. Second one is the hardware refresh. We run Juniper in our core and it's coming to the end of life. So we've been doing an RFP process. We had two vendors for testing. Now the testing identified shortcomings with merchant silicon core, so we're a bit concerned about that. So we are reviewing a hybrid merchant and custom silicon MPLS core. We'll let you know how that goes next APAN. But we're about to start a pilot with our preferred vendor so we can actually use them in the network and live. If you have any technical questions, I am not your person. Aaron is the person, so come to me and I can introduce you to Aaron, and he would happily share our insights and our learnings of this process with you. And the third one is connecting anywhere. So we did some work with our researchers last year to say, what does the future of research look like for you? If you think of New Zealand as a country, we do not have funds for large or scale for large science infrastructure. A lot of our research is applied and out in the field. So what we have been doing is working with our customers to understand what they need. It is not a one size fits all. So we've productized some standard edge solutions, so Wi-Fi, 4G, satellite and the like. And that's mainly for fixed field sites and remote offices. And we're now taking it one step further to actually understand how we can give them a properly mobile solution. So we're working closely with our partners to help do that. And that is it. So thank you. And I've got one thing. I've got some potential free stuff. Whether anyone wants it, I don't know. We are obviously pulling out our Juniper out of the network. We've got some EX switches, some MX380s, some Dell servers. So if anyone wants spares or wants some things to play with, you'll need to pay to get them from New Zealand to your place, and any service contracts and the like, but they will be available mid next year. So just reach out if anyone's got any need for anything like that.
Oh, thank you. Thank you.